In the next few videos, let us solve few trigonometric identities by applying the fundamental Pythagorean trigonometric identities that we have learnt in the previous video. Now let's address this problem. So here we have to prove that sine to the power of 8x minus cos to the power of 8x can be changed to sine square minus cos square x multiplied by 1 minus 2 times sine square x cos square x. So this LHS should be converted to this RHS. So that is the goal here. Now let's start with the LHS here. So sine to the power of 8x minus cos to the power of 8x, this can be written as sine to the power of 4x the whole square minus cos to the power of 4x the whole square. Now this is of the type a square minus b square. However, here a is sine square x and b is cos square x. That is how you have to separate it now. Now let's apply this formula. What is a square minus b square? That is a plus b and a minus b. Now let's write a minus b, which is sine to the power of 4x minus cos to the power of 4x multiplied by sine to the power of 4x plus cos to the power of 4x. Now this part again can be reduced to a plus b and a minus b. So that will be sine square x minus cos square x times sine square x plus cos square x times, now sine to the power of 4x plus cos to the power of 4x, we cannot apply anything here. So we have to adjust this equation so that some a plus b or a plus b the whole square or a minus b the whole square can be applied. So what we can do is, let's write it as sine to the power of 4x plus cos to the power of 4x, which is existing, and we can add 2 sine square x cos square x and also subtract 2 sine square x cos square x. So that way this equation, the value does not change because you are just adding and subtracting the same value. Now let us solve this further. This changes to 1. So this will be sine square x minus cos square x times, now if you notice here, what we can do is we can change this part, only this part, to sine square x plus cos square x the whole square, which is a plus b the whole square. So this will be sine square x plus cos square x the whole square minus 2 sine square x cos square x. Now this again will be 1 because of the trigonometric identity. So now our final solution would be sine square x minus cos square x times 1 minus 2 sine square x cos square x. So that now we have achieved the right hand side which was asked in the question. So this is how you can use trigonometric identities and other algebraic equations to achieve the proofs that are needed. Now let us try to solve the next problem. So here we have to prove cot to the power of 4x plus cot square x is equal to cosecant to the power of 4x minus cosecant square x. So we know there is a trigonometric identity where 1 plus cot square x is equal to cosecant square x. So this is a trigonometric identity which we know. Now, if you want to convert the left hand side to cot square x the whole square plus cot square x. Now what can cot square x be written? So cot square x is equal to cosecant square x minus 1. So let's substitute these values. So this will be cosecant square x minus 1 the whole square plus cosecant square x minus 1. This is the second value. Now let's apply the a minus b the whole square formula. This will be cosecant to the power of 4x plus 1 minus 2 times cosecant square x plus cosecant square x minus 1. So this gets cancelled, and when we solve this, we get cosecant to the power of 4x minus cosecant square x. So this is the RHS that is required. So please keep in mind, we just have to use the trigonometric identities and few algebraic equations, where mainly we use a plus b the whole square is equal to a square plus b square plus 2ab, or the a minus b the whole square is equal to a square plus b square minus 2ab. So this is the main equations that we are going to use. Or there is one more, a square minus b square is a plus b times a minus b. So if we can implement these concepts in the trigonometric identities, we can solve any problems without any difficulty. Now let us solve another problem. So here we have to prove that the left hand side, which is 2 secant square x minus secant to the power of 4x minus 2 cosecant square x plus cosecant to the power of 4x, is cot to the power of 4x minus tan to the power of 4x. Now if you observe the question, the secant values are changing to tan and the cosecant values are changing to cot. We have this trigonometric identity which we can use. 1 plus tan square x is equal to secant square x. That's one of the identities. The other identity we can use is 1 plus cot square x is equal to cosecant square x. Now let us start with the left hand side of the equation. So 2 secant square x minus, so the secant to the power of 4x can be written as secant square x the whole square minus 2 times cosecant square x plus cosecant to the power of 4x can be written as cosecant square x the whole square. Now let us apply the trigonometric identity here. So secant square x can be replaced with 1 plus tan square x minus again 1 plus tan square x the whole square minus 2 times cosecant square x can be replaced with 1 plus cot square x, 1 plus cot square x plus 1 plus cot square x the whole square. So now let's simplify the equation. 2 plus 2 tan square x minus, let's apply a plus b the whole square, 1 plus tan to the power of 4x plus 2 tan square x, then minus 2 minus 2 cot square x, then let's apply a plus b the whole square again, which will be plus 1 plus cot to the power of 4x plus 2 cot square x. Now let's solve the equations. Here what we have is 2 plus 2 tan square x minus 1 minus tan to the power of 4x minus 2 tan square x. I'm just solving the brackets with this negative. Minus 2 cot square x plus 1 plus cot to the power of 4x plus 2 cot square x. Now 2 and 2 gets cancelled. Plus 2 tan square x minus 2 tan square x gets cancelled. Negative 1 and positive 1 gets cancelled. And negative 2 cot square x and positive 2 cot square x gets cancelled. So the remaining values are minus tan to the power of 4x minus plus cot to the power of 4x. So this can be rearranged as cot to the power of 4x minus tan to the power of 4x. So that is our right hand side which we wanted to achieve. So thank you for watching this video till the end. Please share it with your friends so that it will be easy for them to address these questions. Please share this video, like the video, and also subscribe to the channel. Thank you so much.